at chapter 15.7, where we are looking at further definite integral. So in this chapter, what you realize is that questions will actually involve you differentiating some functions, sometimes using quotient, sometimes using product rule, sometimes different rules, all right? And you will get some function after you have differentiated, right? And what you'll notice is that later on, they will ask you to integrate some other functions that looks very similar to what you have differentiated, all right? And what you will need to do is you gotta kind of do some adjustment and compensation by multiplying or dividing some coefficient so that you will make the integration possible of a very complicated function, all right? So we'll look at some examples and we'll use that to help us to understand the concept better. All right, so let's look at example 10. They want you to differentiate this function here. So we'll go ahead and use quotient rule, all right, to differentiate. So d over dx of x squared plus 1 over root of 4x minus 3d. No need dx, we just already is part of dx, so we just go ahead and use quotient rule. So this would be 4x minus 3 to the power of half. Differentiate the numerator, we have 2x minus the numerator, and we will differentiate the denominator. That would get us half 4x minus 3 to the power of minus half times 4. All right, and then the denominator side, we will go ahead and square it. So we have 4x minus 3. Okay. All right, so we will expand a bit further from here, and we will get something like this, right? 4x minus 3 to the power of half, 2x. This would be minus, let's work this out, 2, okay, x squared plus 1, and the denominator of this part of the function would be root of 4x minus 3, whole thing over 4x minus 3. All right, so what we're going to do right now is we're going to make the numerator at the top a single fraction. So we're going to multiply root 4x minus 3 to the first term itself, all right? So what will get us would be actually 2x, and when we multiply root 4x minus 3 is actually plus half to the power of 4x minus 3, so we just have 4x minus 3 left. Okay, and over on this side, we'll have 2x squared plus 1, whole thing over root of 4x minus 3 over 4x minus 3. All right, so we're going to just do some simplification of this fraction. So we will multiply 4x minus 3 with root of 4x minus 3. So what we'll have is 2x bracket 4x minus 3 minus 2x squared minus 2, whole thing over 4x minus 3, 1 plus half, so 3 over 2. That would be your new power. All right, maybe we'll work from here a bit. Okay, we're going to join them all together. So we will have, okay, let's see if we have any common factor. We have 2 as a common factor, we factor out 2. So let's see what we have. 4x squared minus 3x minus x squared minus 2. All right, whole thing over 4x minus 3, power 3 over 2. All right, I think we can finish this up already. So we will have basically 2 of 3x squared minus 3x. What would that be? Oh, I made a slight mistake. Should be minus 1 here. All right, so we'll have minus 1. Okay, so the whole thing over 4x minus 3, and we'll put it in the form that they want us to put it, which is root of 4x minus 3 to the power of 3. Okay, so this is how we show it. So shown. Now, this is quite tedious, but you realize that if you're going to integrate something like what they want you to integrate, actually there's no way to do it. But if you look at this, maybe highlight here, this and this, you realize that the only difference between them is basically a coefficient of 2. All right? So, if we were to integrate, if we were to integrate 3x squared minus 3x minus 1 over root of 4x minus 3 to the power of 3 dx, what we want to do here is we want to try to make it to the previous form, in this case with a 2 in front of the 3x squared minus 3x minus 1. So what we'll do is we'll multiply by 2, okay, and we'll multiply by half on the outside. So we are multiplying 2 and a half as a form of adjustment and compensation. So that would allow us to actually work out quickly. So if we were to integrate 2 bracket 3x squared minus 3x minus 1 over root of 4x minus 3 power 3, it is essentially the original function that we actually differentiate, right? Which is x squared plus 1 over root of 4x minus 3. Okay? And we have to plus a c. Alright, so this is how you solve part B itself. So the concept or the skill is adjust and compensate. Alright? Adjust and compensate. Okay, so I hope it's clear how you can integrate something like that. You can pause the video and look at example 11. Try it yourself. See if you can do it. Alright, and once you're ready, you can check your answer. Okay, now example 11. I need to find some space. Give me a second. Okay, we'll find over here, alright? Maybe I'll just copy this again. See if I can copy this. Just a moment, let me just copy this. I'll put it right here at the bottom. Yeah, so we need a bit more space, so I put it here. Alright, so let's look at how we can solve example 11. We want you, the question asks you to differentiate x sine x. So you do that. So x sine x will be equals to, so in this case you will use product rule, right? So differentiate sine, you get cosines, plus differentiate x is 1, and then sine x. Okay, so this is how you differentiate x sine x using product rule. Now, if they want you to integrate x cosine x dx, how is it related to the one at the top? Now, we want to see if there is some sort of relationship going on. Now, except that you are missing plus sine x, right? So instead of integrating x cosine x dx, what we will do is, we won't do that. We will just integrate x cosine x plus sine x dx. Why do we do that? Because when we integrate this whole thing, we know that we'll get back x sine x. Alright? But what is good is that when you do this, you can split this up into 2 parts. This will be x cosine x dx, and you will integrate sine x dx. And basically, integrating both of it together eventually get you x sine x, right? Because they are kind of related in the sense. Right? They are related in the sense. Okay, so what I want to do right now, I just want to isolate integral of x cosine x. I will bring plus of integral sine x dx over to the left side of the equation. All right, so x cosine x dx is just equals to x sine x minus the integral of sine x dx. Now we have isolated. Basically, we are trying to solve what the question wants us to do. All right, and we go ahead and integrate that part, which is just minus cosine x plus c. Okay, All right, so let's work that out. X sine x, this is plus cosine x plus c. Okay, so that's how this is done. I think for the above example, I forgot to plus c. Oh, I did plus c. Okay, so that's fine. All right, so this is how you work out example 11. Now you can pause a while and try it again if you have not managed to do it. All right, otherwise, we will work on example 12. All right, example 12. So we want to differentiate that first term, and then we're going to integrate something quite similar to what we're going to differentiate. All right, so let's differentiate that. So we will use, in this case, product rule to help us to differentiate. Okay, so this would be x cubed times half of 2x minus 1 to the power of minus half times 2. And we're gonna plus, I'm gonna put a plus here, all right? And then this will be 3x squared of root of 2x minus 1. All right, we can simplify it further. So this would be x cubed over 2x minus 1 whole root plus 3x squared of root of 2x minus 1. Okay, so what we're going to do, we actually want to join them into a single fraction. The reason is because then it will look more similar to what we're going to integrate later on. Okay, so x cubed plus 3x squared, we're going to multiply with a root of 2x minus 1, that will be 2x minus 1. Okay, and then whole thing, we have the similar denominator, which is root of 2x minus 1. Okay, work this out a bit. So we have x cubed plus 6x cubed minus 3x squared, whole thing over root of 2x minus 1. Okay. We can simplify that. I think what we will get is, let's see, 7x cubed minus 3x squared. All right, whole thing over root of 2x minus 1. Okay. All right, so we will get here. Now, we want to integrate that 7x cubed minus 3x plus 5 over root of 2x minus 1. Notice that the difference between what we have differentiated and what we need to integrate, there's a plus 5 missing. All right, so what we can do is we can just go ahead and integrate that function. Just write it down. We're going to put a plus 5 dx, all right? So what is basically the difference between the top and the bottom? One is that there's a plus 5, all right? So we can go ahead and split this up. 7x cubed minus 3x squared over root of 2x minus 1 plus, we're going to put a 5 here, and we're going to put root of 2x minus 1 dx. All right, so we can just split it up like that and realize that now with the splitting, this is exactly what we have done earlier on. And the next integral of 5 over root of 2x minus 1 actually can be done quite easily. You don't have to do anything very special. We can actually do that. So we'll go ahead and solve this. So we're going to replace this with x squared root of 2x minus 1 plus, and over on this side, if we don't integrate this, this would be basically 5 2x minus 1. We're going to add 1 to the power of minus half, so we will get half, and we're going to divide it by half and multiply with the differential inside the bracket, which is 2. All right, and then we're going to plus c. So all in all, we are going to have maybe a bit small right here, x squared root of 2x minus 1, and this would be basically 5 plus 5 or root 2x minus 1. Yeah, the half and the 2 get cancelled out, plus c. Okay, so basically that. You can factor out the root 2x minus 1 and then just combine x squared with plus 5. All right, that is also fine. Oh, sorry, I made a mistake. Should be x cubed, not x squared. Because here is x cubed. All right, so I hope this is clear. How you solve part 15.7, example 12. All right, so I'll see you in the next video for more examples.